In the previous lesson, we learned how to use the transactional outbox pattern to achieve the at least once delivery guarantee. This means our messages might be delivered more than once, and that's why we need to make sure that our message handlers are idempotent. Idempotent handlers are handlers that can be called multiple times with the same input and always produce the same output, without introducing any side effects. So, for example, if the workflow for a given building already exists, we should not create a new workflow. Instead, we should simply ignore the message. Currently, if our building service crashed right after sending a message to the message broker, the message will be sent again when the message recovers, leading to duplicate workflows, which might of course lead us to having data inconsistencies, duplicates, etc. In this lesson, we'll learn how to use the inbox pattern to solve this very problem. The inbox pattern is fairly similar to the outbox pattern that we covered in just the previous lesson. The inbox pattern, though, is more useful on the consumer side, where we have a dedicated table called inbox, which stores all incoming messages, instead of outgoing messages as within the outbox pattern, hence the difference in their names. This consumer service that we will create periodically checks the inbox table for new messages and subsequently processes them. In contrary to the outbox pattern, we first save the message to the inbox table and then return ACK, or acknowledge the message, to the message broker. This way, if the consumer service crashes before sending ACK, the message will be redelivered to the consumer service again. Hence, the guarantee is known as at least once delivery guarantee. However, with the use of the inbox table, we can actually easily check if the message was already processed or not, which usually lets us achieve the exactly once delivery guarantee if we want or need it. Alright, enough theory. Let's see how all of this works in practice. Let's start by creating a new inbox module in the Workflows service application with NestGMO inbox. Again, instead of generating this module in the Workflows service project, we could technically generate it in the libs folder, making it available to all other applications. It is, after all, very likely that we may end up needing this functionality in other services after all. So once again, as an exercise, try to generate a new library yourself and move the inbox module there. Next, let's create a new inbox entity with a few columns in the inbox module. Next, let's generate a new inbox service TS file in the inbox module with NestJS inbox. Once the file is generated, let's inject the data source provider using the standard approach. Next up, let's declare a new process inbox messages method that will be responsible for processing messages from the inbox table. Note that this method is slightly different than what we implemented in the transactional outbox pattern lesson. First, instead of returning unprocessed messages, we're passing them to the process function. This function will be in charge of processing the messages and updating their status to processed. The reason we chose the callback style approach here is because we want to leverage the transaction method from the data source class. This method will automatically roll back the transaction if an error occurs. This way, we won't even have to worry about rolling back the transaction ourselves. Okay, so let's save our changes and open up the inbox module TS file. Here, let's import the typeorm module for feature method and pass in that new inbox entity to it. Great. Let's also make sure to export the typeorm module and inbox service provider so we can use them in other modules. Now that we have the inbox module in place, let's open up the workflows module file and import the inbox module there. Next, let's open up the workflows controller file and inject the inbox repository provider using the inject repository decorator like always. Next, let's scroll down to the create method and update its signature to accept the context object. We'll need this for acknowledging messages in just a moment. Inside the create method, let's first insert a new message into the inbox table if it doesn't exist yet. And afterwards, let's acknowledge that message. Perfect. Now, to instruct RabbitMQ to immediately redeliver the message if that SQL query fails, we could wrap everything in a try-catch block and knack the message in that catch block. However, this might not be ideal because it could potentially cause a lot of load on the database, similar to brute forcing. More on this in a moment. Now, there are two more things we need to do before we can test everything out. First, we need to update the workflows service main TS file and set the no ACK option to false. This way, the message broker won't automatically acknowledge messages. Second, we need to create the workflows inbox processor file in the workflows module with the following content. Next, we'll inject the inbox service using the standard constructor-based injection. Now, let's use this service to process any unprocessed messages. Next, let's iterate over all messages and process them in parallel. In the code here, we're checking to see if the message pattern is equal to workflows.create, and if so, we're going to call the createWorkflow method. So let's create this new createWorkflow method. And let's break it down. First, we need to retrieve the workflow repository from the Entity Manager instance. Next, using the create method, we create a new workflow entity and then save it to the database using the repository's save method. Last but not least, we update the message status to processed so that it won't be processed again. Since every operation is already wrapped in a transaction, all these changes will be committed to the database only if all operations succeed. Now, with this class in place, let's register the Workflows Inbox Processor Provider in the Workflows module file. And last but not least, let's import the Schedule module in the Workflows Service module file so that our background job or process can be executed properly. Excellent. Let's save our changes and head over to the terminal and make sure everything is still up and running. If there are no errors, let's create a new building using curl. Let's wait a little bit. And as we can see, there's that created workflow log message, which means that the workflow service successfully processed the message. Fantastic. However, since we're running 3 separate workflow services in parallel, all 3 nodes will process the same message at the same time. This is why we should rather use Bull or BullMQ repeatable jobs that support locking and can be executed only by a single node at a time, instead of the Nest.js schedule approach we're using for simplicity's sake in this course. Alternatively, we could implement a locking mechanism ourselves, using, for example, Redis, with the use of the setNX instruction. We could create a lock that would be acquired by a single node at a time, and once the job is completed, the node releases the lock using del. We could also take another approach and try to split the workload between the nodes, so that every node selects only a subset of messages to process that doesn't overlap with any other nodes, instead of simply ordering all messages by their creation date. This way, we could process messages in parallel without the need for locking. However, this approach is not always feasible, so keep that in mind. In this lesson, just to finish things off, we'll implement a very simple locking mechanism using the forUpdateNoWait clause in the SQL query. This clause allows us to lock rows in the database and prevent other transactions from reading them. If another transaction tries to read a locked row, it will fail immediately with an error. This way, we can ensure that only a single transaction can process a given message at any given time. While this approach works, it's far from ideal, as we'll have 2 nodes running cron jobs that basically do nothing but fail. This is why, ideally, we should instead use one of the other approaches we just mentioned a moment ago. Alright, so let's head over to the inbox service file and update the process inbox messages method, adding a new configuration object called lock. In this example, we're going to use the pessimistic write mode with the onLocked option set to no wait, which means that our SQL query will contain the forUpdateNoWait clause. ForUpdate causes the rows retrieved by the select statement to be locked as though it's for an update. This prevents them from being locked, modified, or deleted by any other transactions until the current transaction ends. This means that other transactions that attempt to update, delete, or select for update on these rows will be blocked. Since no wait is specified, if another transaction has already locked any of the selected rows, any other service trying to read those rows will fail immediately with an error as well. Alright, so let's save our changes and head over to our terminal and make sure everything is up and running. If there are no errors, let's create another building using curl. And great, as we can see, only one workflow service processed the message. The other two failed with an error. Fantastic, everything worked. So just to wrap things up, remember that locking tables or rows should be used with caution, as it can impact the performance and concurrency of your application. We had to do it here just for simplicity's sake, as we wanted to cohesively wrap everything up in this lesson. But as we mentioned earlier, we'd want to go with other approaches like BullMQ, for example. More importantly, always make sure to test whatever locking strategy you choose thoroughly to ensure it behaves as expected and doesn't cause any adverse effects on your system. Additionally, be mindful of handling potential errors that might occur when using no wait to avoid application crashes or unexpected behavior. Also, just remember that with the current strategy, 2 out of the 3 workflow services will always fail with an error. This is why for production applications, you should always choose one of the other approaches mentioned earlier in this lesson, as they will bring you other benefits to your application as well.